Thanks for joining today. My name is Sureshkumar. I work at eBay. Today's topic is about from dashboard to defenses, how we can build autonomous resilience at scale. I'll start with a typical scenario everybody faces. How many of you finish at 2 a.m. in the morning? Typically, 2 a.m. pager is regular where people get up from the bed, try to log in, try to look into the dashboard. There'll be hundreds of dashboards, look at everything, trying to figure out what's going on, try to identify the issue, try to contain the issue. Today's topic is about that. How we can improve on that experiences. Instead of having 2 a.m. pages, how we can build a system that can be handle itself. You might think at that time saying that, what can I do to make sure the system is fixing its issue itself? Today's presentation is more about how we achieve that in our system. So this 2 a.m. thing doesn't scale, especially people are tired handling issues, and then people tend to make mistakes. Okay? Human errors are always possible in these scenarios. Okay? Especially this is true when it comes to large scale systems. Okay, when there are hundreds of microservices and using humans to or the 2 a.m. pages may not help to scale at that level. We need the better system to handle at that level. Also, if you look at a dashboard, doesn't do anything. It just gives you the information, and people need to look into to use the dashboard. Okay, dashboard is fire alarm. It's alarms, but it doesn't automatically try to enable the sprinkler. Okay, so there need to be somebody to look into or hear the fire alarm to activate. So dashboard helps in the way there are fire alarms are needed, dashboards are needed, but that just tells you the information. We need much more than that. How to automate or scale, use the signals to automate is one we are focused on. And the mandate is clear in this. So we need to build reliability as part of the system. It is not reliability as an afterthought, or we can build it later. When the systems are getting built, reliability need to be thought about it, and then we need to build it as part of that. So that's a big reliability challenge we are facing. The traditional way we do doesn't work. We need to look into the new ways and build a reliability part of our system. So the big observability character is about the vanity metrics. We have a lot of metrics. People, every time there is an issue, we will add more metrics. Okay, there will be more dashboards which is getting built in. There will be new graphs and new things people can use it. Okay, but especially humans can't read millions of data points at point in time. It will be a limitation for everybody to read. So when there is a wildfire happening, you are trying to contain with one fire extinguisher, it is not possible. If humans are like that, there will be especially in a large scale system with multiple services and multiple dashboards, multiple metrics, there'll be a lot of noise for people to look into and act on it. Okay, so the traditional way of our collecting metrics need to be changed. Okay, modified. So the old way is collect everything, hope somebody will look into the dashboard and then act on it and then work on it to fix it. The new ways are changing. Okay, so there are Google SREday document which talk about SLOs, SLIs, and error dashboard. That's where we also started utilizing it. Okay, so mostly instead of system metrics, collecting how your systems are doing, we are moving towards the user experience based. Okay, so the SLIs, I'll talk a little more about that in the later slide. But this is how your user experience are behaving. So if you are having a website, how much your website is available is the metric you want to track. It's not about how your systems are behaving. So the traditional metric to the new metric is the new way to track it is about SLI, SLO, and error budgets. Okay, that's the way we started tracking, which will give you a real picture of how your systems are doing. And this we can use that signals to automate a lot of these things. Again, there are a lot of proven patterns in the industry, which we started adopting it. So first thing is SLI, SLO, and SL error patterns. So this is, you define an objective for your experience. Assume it's an e-commerce site. Okay, the checkout is one of the critical experience. How much percentage of the time the checkout need to be available? So I will say 99.9% this checkout page need to be available. That is my SLO. Okay, so SLI is how you measure SLO, and which is the metric we will measure, given 30 days, how this metric is performing, how many minutes the site is not available, so checkout is not available. So error budget is how much budget we have to be okay to run the business. So if I say 99.9%, the site need to be available, it means that we are okay to not available for 0.1%. 0.1% is an error budget. So it is typically translate to like, right, it's around 43 minutes in a month. So I'm okay to have my site down for 43 minutes. Okay. So you continuously track as an SLI, and then we use this as a signal to do anything. Okay. So if there are more error, you are losing error budget, it means that you need to slow down. Okay? So you need to look a possibility how you can improve the stability of your site, because you already overburn your budget. Okay. And if there are less budget, it means that like you have few more errors to make, so you are okay to move your velocity and move faster. So this error budget gives the clear signal of automating a lot of these things. So we use this error budget as a release gatekeeper. So if there are more error budget, it means that we can release more frequently. We can add more new feature more frequently. If there are less error budget, it means that we need to postpone the release, make sure our site is stable, so that like we meet our budget, we meet our business goals. So this is one of the bigger change we did than the traditional metrics, logs, and errors what we collect. And the second, other things are like read is another framework, whereas like rate, error, duration. So it's a way to collect how much is the traffic you are getting, what is an error percentage, and then what is the duration it is taking. And that's another framework we use to collect that. And then Google Golden metrics, which is like latency. There are 4 metrics in Google Golden Signal, which is latency, error, saturation. I forgot traffic. Okay, so these 4 metrics we started collecting as part of this, and users mainly use for how you collect resource utilization. Uses utilization, saturation, error rate, especially like the infrastructure side. We track these metrics, and I mean we started standardizing that across all our applications. Earlier, like every application have their own way to track, their own way to measure. Now with these things, we are standardizing it. We are moving to a common terms with everybody in the company can use that and then measure their systems. So like I said, there will be 100 dashboards may not help, like it is for noise. We are moving towards like even one golden dashboard where you can see everything which is needed instead of having or few golden dashboards instead of like a lot of dashboards, which is common across all our teams, all our applications. Okay. And so OpenTelemetry is a kind of a toolkit which is used to collect all the metrics. So we also adapted that. Okay, generally to summarize on the previous slide, like we started moving from the traditional way to collect the metrics to the modern metrics and modern signals to collect, and we standardize that across all our things. And then we use some of these signals to control some of the other parts as well. Metrics, traces, and logs are important pillars on observability. This is standard. We started collecting even before, but we did some optimization to scale it better. Okay, so like when your systems are scaling, these are heavy data which you are storing. Okay, so if you start collecting everything in the log, your log system also need to scale. Okay, when we are scaling with hundreds of microservices with all these things, you need to consider like what is the right thing to capture so that you are not like increasing the too much load on collecting whatever doing. So we did some optimization overall around metrics, traces, and logs. Few things I want to highlight as when it comes to logs. So we introduced a severity level of the log. Okay. So developers want a lot of logs, detailed logs to debug. Okay. But you don't need everything at every time. So we introduced severity called like error, warning, debugging, so that we control what is needed at all the time, what can be sampled, and we can enable it if needed instead of doing it everything every time. That's something we changed and we collect logs. When it comes to the traces, like traces again, like unique ID you generate in the distributed system, so that which you can use to identify or how a particular request is doing in a particular distributed service. Okay, so traces again expensive. We use OpenW3 standard tracing frameworks to do it, but like we can't do tracing every time. So we did sampling. Okay, so when you sample it, there are a few patterns which you adopt. One important thing which is when you want to sample it, instead of random sampling, we adopted something called like tail-based sampling, which means that you instead of decide whether you need to sample at the start, you decide at the end based on how that request is flowing through. If the request results in error or request is a slow, you want to sample that instead of just sampling all success requests. Okay, so we use tail-based sampling, which helped us to observe our system more better. Okay, so basically we did optimization around metrics, traces, logs to improve than what we do. So this help us to better to collect the metrics and then better to scale to the next level. So other than these metrics, whatever we talked, we also improved our observability beyond our basic metrics, which is one of the common problem or common cause for any production incident is code rollout or feature changes. So, I mean, we want to capture the change also as part of our metric tracking so that it is easy to triage or align with what is the previous change. If there is a production incident, the first thing we'll look into is what is the previous change. Probably that might be the one of the potential root cause for us to act on. So instead of going in different places to figure out, so change management or change trigger, whatever is getting changed, anything major, which will be captured as part of metric systems itself, so that it's one place for everybody to look into it and then act on it. Okay. So the second thing is the metrics mostly around backend servers, how our backend systems are doing, how our services are doing, especially less for the front-end application, especially the UI-based applications, where actual end user is using a browser to connect with your system. If there are some issues happening at a browser, your metric system doesn't capture all those things. Okay? So again, based on our learning, so there is based on incidents, we learned that, and then we started doing client-side tracking itself. It's a client-side tracking as well, meaning when there is a JavaScript error, okay, when there is a new code change, we are rolling out, people are loading it in a browser and then it fails in JavaScript. Traditional metric system doesn't capture that, right? So we extend our radius beyond backend system to even for client-side errors. So if there is JavaScript error, it will be locked to our system. It will be part of our metrics to track, and then we can figure out how many people are having what kind of JavaScript error. And it is not JavaScript error. It's also about the success metric, how much they're successfully able to load and how much latency. There are more metrics we started tracking and client-side. Okay. There are other incidents like CDN is a major part of our ecosystem. Okay, so CDN plays a bigger role how the user experience to be. A lot of our experience are cached. When users try to access it, if they access from CDN, they see a better experience than loading it actually from our servers. Okay, so we need to understand how our CDNs are performing as well. What is the cache hit ratio our CDN is doing? If there is too many misses in CDN, it means that something is wrong. So it is not a good user experience. So we started collecting the even edge, where CDN metrics, all those things we started collecting beyond the server metric. Okay. The other thing is about capacity and cost. Capacity also plays an important role. It's an infrastructure. It is also needed for the system. I mean, we want to see how the capacity also performing. If some server is reaching 80% of the capacity and we are burning at the rate of 5% every day, it means that they need to be alerted and then people need to work on to instead of making an incident. So capacity also need to be tracked. So we also added capacity as part of our tracking as well, how our resource utilization happening, how we are utilizing the resources. Okay, and the other thing is about the cost. Okay, it's not directly related to observability or anything, but there are different operation needs different kind of resourcing. There are some resourcing which needs a heavy cost. So ultimately everything is boiled down to cost and business. So business want to understand what is the cost we are incurring, all these things. So we have started tracking some amount of cost as well as part of our tracking. So basically, in observability, we moved from vanity way of tracking with the new SLI SLO signals. We increase our radius to track more beyond our system. Increased us. So the next thing is about how to detect anomalies. So generally, we used to have a static threshold to control, but the static. So our traffic pattern is not normal. At 2 a.m. traffic might be different from 2 p.m. traffic. Traffics are always changing. It is not a holiday period might be different from a regular period. So our traffic is always changing. Our patterns of traffic is always changing. So we can't have a static threshold to limit any of these things. We need to have some dynamic way of identifying the patterns and then limiting it. So basically, we involved a lot of ML model. We customize some of the open source availability to do that which will take all the metrics and then it identified when there is an anomaly in the capacity, and then we use that as a signal to act on it as well. So browser errors pattern also will be used. There will be multiple errors, and then we need to identify what is the right error for us to go after. And this AML models help us to do it. Like I said, we customize some of the open source models which are available in the market and then for us to use. We cover a lot of these things. The old way is alert, and for human to act on it, human will look into the dashboard and then identify and fix or address all the things. The new way is alert, and then alert as a control signal. Like I said earlier, if there is an error spike, okay, so our systems will automatically identify error spikes and then try to roll out the previous thing which might happen, which might be aligning with the rollout. So alerts are used as a control signals. We also introduce something called multi-burn alerts. So basically, for the same metric, there will be two kind of alerts. One is to identify high burning issue and then slow burning issue. So we have different thresholds which will meant for to identify different kind of issues. So the goal we went over is page only when if it is necessary, when the system can't fix it, only then we want to involve the human. So a lot of these control signals I'll try to automate some of the things like rolling back the previous code, rolling back the previous feature config, or restarting the machines, rerouting the traffic. A lot of these things are based on our metric on error trends and other things we were able to automate it. So another important thing is establishing the trust, right? How do you establish the trust of the new system? Then in which we went with the tire-based approach. When we started, we want to start with something safe and reversible to automate. And then we went to more progressive where humans are involved when some decisions are made, and then to finally notify. So we approach tire-based approach to bring the visibility of how we automate. So along with all these things, we also add a lot of resiliency design pattern as part of our system to see how we can improve the resiliency of our systems. Okay. Again, these are standard patterns which is available in the industry. So we took that and then applied in our system development as well. Circuit breaker helps if one service goes down, some different service goes down, instead of bringing the service down, how you can be more resilient. So service A is dependent on service B, and service B is down. Service A will open the circuit so that service A is at least resilient and then support this traffic. So we use the circuit breaker pattern for that. Bulkhead is again how you isolate one component failure impacting all other systems. So again, we want to isolate some of the use cases or components which might impact potentially other cases. We isolated that and then deployed it to a different application or used different thread pools to handle that in the same application. We followed that pattern to improve the resiliency of the system. We try with the exponential backup is another pattern, when one service goes down, how you retry it, instead of keep retrying or overloading the system, if there is a failure, then before you try it, you wait for it, and then you increase the wait time exponentially and give a time for the system to heal itself. So we tried that pattern and it helped failover load balancing, the standard pattern, and CQRS and SAGAS, a couple of other patterns which I want to cover is especially when you are handling an application which handles write as well as read. So the CQRS is command query responsibility segregation pattern, which the proposal is you segregate your read from the write so that one won't impact the other. You have the read, which can be powered by read replica, and then write is in a different application which will write. So at least if there is write heavy, so it is not impacting read, and if it is read heavy, it is not impacting write. So we use that pattern. Saga is again distributed transaction pattern where how you handle errors in a distributed transaction systems. So we applied standard industry patterns to improve the resilience of our system. And this is also one of the big pillars which helped us to automate in our system. Okay, the another important thing is, so far whatever we talked about is how to monitor our production system when there is an error, when there is a metric, and then how do you do it. But the important pillar is, so one of the main root cause of the production incident is any new changes happening in the production. Okay, new code changes, new feature reloads is the main cause. Okay, how do you make sure your new code is more resilient, which is not impacting your production system, which is already stable, which is working fine? So we improved resilience as part of our delivery pipeline itself, meaning we used to have a lot of manual deployments, which means that a human used to validate the new code changes, validate the new features, test it in a staging environment, test it in a sandbox environment, manually approved and manually roll out it and manually watch that. And then before a feature is going live, it was the old way how we did it. The new way is like we automate end-to-end, like right, meaning there is an CI/CD pipeline. As soon as people check in, we run automated test cases, automated pipelines, which will test everything. And then we introduce canary and progressive rollout, meaning your code will be like released to a production in small increment where your metrics are used to watch. If there is a, so that your canary rollout will put your new code or new feature into a 1 or 2 boxes and then see how it is performing, how is there is an error spike. If there is an error spike, then it will automatically roll back. If there is a no error spike, then it will proceed, go to the 10%, 100%. So that is the big change we did, right? Automated end-to-end resilient pipeline, okay? So a couple of things which you introduce as part of end-to-end pipeline, which is important, is traffic mirroring or shadowing, okay? Especially if your application is like, right, or if your thing is a read-only application, this really helps. Like automation is a big part, and we can't always cover every use case as part of automation. But this traffic mirroring really helped us to automate, meaning, so when before you roll out the code to production, you put it into one box, you mirror the traffic like from production and then compare the results. So basically there is a one traffic which goes to actual production environment, gets the response, and then your mirror traffic goes to your new code and then gives the response, and compare it to see how it is performing. And we are able to cover most of our regression through that, right? So the traffic mirroring part of our delivery pipeline is one important big change which helped us. The second is the feature flags, okay? So earlier, I mean, we were not using much about the feature flag. Every feature is like, right, controlled with few parts, but especially if you fix feature across different experiences, now control the feature flag. We want to roll out which feature off. And then it means that you're pushing your new code to production, but without the feature is enabled. So it means that it need to behave like the old system. And then feature turning off is then again another rollout which will help to enable the feature, and the same thing goes through again. And then we have a detailed feature flag to control every level, so that if there is an issue, we don't need to roll back, we can pull down the feature, okay, with a feature flag. That's another big change which helped here, okay? So we change from like, right, shift left, meaning like, right, humans are involved prior to rollout to humans are involved after the rollout, okay? That's a big change which helped us to make our system more resilient. So the outcome of that is like faster deployment, improve the velocity, okay? So another thing is the dynamic rate limiting. So oftentimes, like, the issues are not because of your code or your infrastructure, okay? Especially if your application is public facing or public facing APIs, people will overload your system, okay? So not expected or unexpected. So you will get a lot of traffic, okay? So your system, they can bring down the system if you are not like handling or rate limiting the external traffic or people who are using it. It is the case even for internal system, some other batch or some other application which might have some issues, which might load your system, it can bring down our system. So we need to rate limit our application, which is important part of the learning which we did. Is that's why again static limit doesn't help there. So we want an adaptive limit, like meaning again we leverage all AI pipelines to detect what is the normal traffic versus like unexpected traffic to limit that. And this prevented like almost 30% of our incidents, okay, with this dynamic rate limiting support. Okay, this is the important principle which I want to talk about is SCAR decisions principle. The idea here is, right, when you start up, when we want to, every time there is an incident, it's SCAR, and then we want to analyze how we can improve our system as part of the incidents. Whatever I'm talking, or whatever I talked about is an outcome of the incident which happened on our system. Every incident is an opportunity for us to learn and like how we can improve our system, how we can automate. So one of the main key questions, we do blameless retro to identify what is the real reason and how we can improve for every incident. So one of the main questions in the incidents is how could this can be automated? And auto-detected, auto-corrected is part of our blameless retro. And then we will invest the time to automate that incident so that one incident won't repeat. Like maybe it's a new incident, but same incident won't repeat, okay? So that is something helped us. SCAR decisions is like it's every incident is a kind of SCAR, and then you learn from the SCAR and then improve your system. And whatever I talked about is like it improved based on that. So another important thing is how you create a trust with the people, okay? That is more important. So when we started, like first time we were talking about automation, like and nobody trusted that. There were a lot of concerns about like how this can scale. It might impact negatively, okay? It can cause more issues than automate. So building the trust or within the team is the main pillar. Again, we approach this in an incremental basis. Let's start with small, where we can automate and then we can improve on. That's helped us to increase the trust. When people started seeing it is working with the small cases, then they started believing it, then started investing more. That helped us to improve it. Also, whenever there is some action, something is happening, we want to be transparent, like, right, log it, like why certain things are happening, so people understand, like, and the transparency is another angle which helped us there. So I think I'm running late, so I'm just
Sorry, one question. Sorry to cut you. Is Ganga, nobody here is Ganga, so I guess you can run late because we have another vacant spot. After we finish, we'll resume at 2 with Anjan Dash. Yeah, all right, let's do that.
Okay, thank you. I have more time. So another thing is the business-driven resilience. Okay, not every user experience are same. Some experience are critical, some experience are not critical. Like especially in an e-commerce site, like right, checkout or the payment is critical part of it. But if you compare it to recommendation, may not be that critical. It is critical for the site to run, but it is not critical. So business-driven a lot of these things to prioritize which need to be focused on first, which can be prioritized later. So resilience, where business inputs are also necessary for us to start. When we started, we want to go after the more critical system than less critical system. So we want to prioritize and improve the resiliency on the more critical systems. So that's another thing. And so we talk about a lot of things. We talk about observability, we talk about dynamic rate limiting, culture change, all those things. But summarize everything, this is the blueprint for automation system. Okay, so our metrics become actionable signals. Instead of just metrics sitting on a dashboard, we use metrics to action it. If there is a high error, it means that slow down our rollouts. If it is a more error, slow down, more error, warning, slow down our releases. If it is high error, release. If it is low error, it means that you can move faster. So metrics are actionable signal. Alerts become like a closed loop mitigation, which will result in solving the issue instead of just like alerting the people. And deployments become autonomous pipelines. So it's not a manual anymore. Like, right, there is, as soon as code is checked in, our pipeline will take care of running it, pushing to the production. If there is any issue, it's rolled back so people can fix the issue and then let the system to deliver or changes. That is including any feature wire on, any new changes happening on the site is through this delivery pipeline, end-to-end delivery pipeline, instead of human involved there. And our limits become adaptive safeguards, and our firefighting, which have become a proactive automation, and fear of automation. That's where we started. It become a trust in automation that helps us to automate a lot of our things. So I want to finish this with stop watching the dashboard, start building it, and reliability is achieved through the autonomous resilience. And the last thing is reliability is not just about duty. Reliability is about autonomous resilience. Every incident is an opportunity for us to learn and improve the system. And that's how we started, that's how we are now. And it is an incremental process. It's not happen everything over the night. You can't do it. Again, a lot of things associated with it. You move from one step to another step gradually. That's my end of the talk. Thank you for listening.
So how do you the resiliency of your infrastructure? I'm not talking about the golden signals or application. Whatever you showed, right? Having a circuit breaker, exponential back off, those are like resiliency from an application point of view. I'm talking about from system where the application is deployed, right? How do you ensure the resiliency of the infrastructure?
It's a great question. Like I covered a little bit of that, is meaning like there are frameworks like where we collect how our infrastructure are performing as well, like similar to how our applications are performing.
I'm not talking about how it performs. I'm talking about while provisioning the infrastructure itself. So let's say for an example, I want to deploy an application. Let's take a typical example like a storage S3. If I provision S3 bucket, I know like the data would be there because AWS guarantees availability as 99 point some nines. But what happens if something happens to my S3 bucket? I'm going to lose the data, right? So how do I ensure that kind of resilience in terms of RTO and RPO while provisioning it, like a shift left approach? Are you following any framework, or like what we do in our organization is while provisioning itself, we ask them to run a service called Resiliency Hub Assessment. You upload the state file or your resource group, it will take resiliency. If the score is more than 90%, you're good to deploy it.
Yeah, it is not visible to my level. Okay, I am part of the application side, not at the infrastructure side. But I'm assuming the similar things happen on that side as well, meaning like AWS guarantees it. So I'm not sure exactly what internally they do to guarantee that. So whatever I covered is not at an infrastructure level. It is at an application level. Thank you.
So for the tail sampling, you said that only for errors, we somehow sample the whole thing.
So you sample it when instead of sampling like right, you start at the decide like whether this request need to be sampled at the start. You decide at the end if there is an error, it's a candidate to sample. Again, you sample it, not you capture every error. So your sample has more errors or more like requests which has needs an attention than more successful requests. So sampling.
What is the framework for that? Like you have to store all the logs and then after that sample. Random sampling is not
So
possible.
meaning you decide to store at the end, not at the start. Okay, so
Is that like P95 latency? You leave the first 95 and then you take the tail samples, tail request, right? Is that what you're saying?
So when tracing, when you want to, he is referring to the trail sampling for tracing. So when you want to store tracing, you instead of you decide to trace, we want to sample it. Right? It's not like we can trace every request. Okay? Every request goes through the hundreds of microservices, and then tracing everything is expensive. So one of the pattern we process is tail-based sampling. So you decide based on how the request is behaving. If the request is result in success, probably you can ignore it. You don't need to sample it because it's success record. But when the request is such an error, you want to store that request end-to-end. You want to store that trace. So you can go based on, you can decide based on how the request is performing. Okay, so you can decide to sample or store based on how the outcome of the response.
Is the in-house built solution or is it?
It's an industry pattern available.
So I think all that thing of open telemetry hotel, they do all the sample like they provide feature element like jar files where we can do head sampling and tail sampling. Both way we can achieve the open source telemetry and all that.
The amount of logs will be high. I'm just thinking you have to store all that until you make a decision.
Yeah,
And the infra cost is higher.
yeah. So before showing all the logs, they do sampling means they check what kind of request what kind of data is this performing, and they just store the whatever you need to store record data, not the everything the log point of view. So that way we will show in the tracing when we do hotel telemetry, just on that part.
So what you can do is you can put it as a sidecar or an agent running in the node. You can run it as a sidecar and decide then and what to forward for storage and not. Or if it is not too high, you can collect it across applications as an agent in the node and then forward it, filter there and forward it. So you get the span IDs of the errors. You can just store those traces for
Space traces. You can have multiple spans ID, so that way they can collect.
Do you have any specific window for performing this deployment? You do all the time.
Yeah,
Because the results
there are
are
multiple applications, there are multiple teams, so there will be always some deployments happening. Yeah, we don't restrict. But when we started, we do deployment only when the people are in office, regular working hours, less traffic. That's when we started. Now it's like as soon as you check in, people review, merge the code, the pipeline starts, pipeline deployed. We don't know when it.
Are you guys building any product or like you have own?
I didn't get. So whatever I talked about is like how the application development is generally done so every team has like a minor variation.
Do you perform any chaos testing to ensure the reliability and resiliency of your application, like load testing and stress testing?
Yeah, we do, but not for every change. It depends. Like load test, if it is a bigger change, which we feel it needs a stress test, we do like other security testing, like security testing as well. Depends on the feature, but not for every change.
How do you make your limits dynamic? Checking.
So that's when this AML helps us role. Right? So it's not, we have a dynamic limits. So you feed all the data to ML model, which will help us to predict the limits for you. Again, we have some of the open source models customized and use it for internal needs. So I don't have much details about the models, but that help us to decide.
But still it's it's still static. You just change it, is it?
Sorry? No, you see, when the new request comes in, or this goes to the model decides whether the new request can be allowed or it need to be restricted or need to be limited. It's dynamic.
Okay.
So instead of you decide up front saying that this user has like X limit, you count the number and then you block it. That's a static limit you have inside. It will be more dynamic system will decide like whether that request need to be allowed or need to be blocked.
It's like a CI/CD that you input all of this throughput and decide.
Sorry?
Is it like a CI/CD pipeline that you input all of the throughput and they will decide? Or they will just.
CI/CD pipeline, like in that, right? It's a production system, okay? Okay, so where there is a trained model which is running and your request will be given to that model to decide.
So this AI is the one that will.
You mean to say we will send all data to AI model will decide what is the limit for that particular request.
Thank you.